Happy Thanksgiving, everybody. I am using today to start working on a Battlezone PCB set. I've got my harness all done. So we're going to the main board and we're going to the auxiliary board, and then I use my interconnect that I made when I was doing Tempest repairs. It's the same pin out, so it's the same thing. Just got this one thrown on the bench. I did kind of reseat the ROMs because this does have old Atari sockets. But I reseated them all. This is a nice unhacked board. It's never had any work done on it, doesn't look like. So I'm going to go ahead and fire it up. This is the kind of board I like to work on because it's never had any work done to it. So I don't have to worry about previous work. So I'm going to go ahead and fire this one up and see what happens. Got her power LED, that's good, on both boards. And look up at the monitor. It doesn't look like anything's going on. You can see our spot killer light is on. So it's not doing anything. So since it's not doing anything, I think first thing I'll do is I might as well grab the oscilloscope probe and check some basic clocking signals and stuff like that. We'll start with that. And then I believe eventually I'll end up throwing the fluke on it and making sure I can get to all the RAM and the ROM. First things first, I'm just going to fire up the oscilloscope and probe some basic signals. Okay, as you can see, I've got the oscilloscope fired up, and what I'm going to do is just kind of go through some basic clock signals. So this is the 1.5 megahertz clock signal that operates the CPU, and you can see it is fine. This is the read-write signal off of the CPU, which is fine. This is the secondary, the theta clock, theta 2 clock off of the CPU, which is fine. And a couple vector ROM signals. These are access to the vector ROM signals. So those we got some basic signals going on here, which is nice. So that tells me my clocking is good. So the next step I'm going to do is I'm going to throw the fluke on it and do RAM and ROM checks. Okay, I'm doing some stuff with the fluke here. And this RAM section right here is 2000 to 2FFF. And it all tests out okay. That's the video memory and the RAM memory and all that. These two 2114s right here, these are the CPU's working RAM. And one of them is bad, as you can see. That's it. Yeah, I'll repeat it. And basically I'm doing a RAM short at 0 to 3FFF or 3FF, and it's giving me that the upper RAM chip, the upper 4-bit RAM chip has a bad output. So I'll have to look at the schematic and find out which one of these two guys right here is the upper RAM chip, the upper nibble RAM chip, and replace it. And I'm having all kind of ROM problems. Sometimes it'll read them, sometimes it won't. I think I just got to replace sockets everywhere. These sockets are so bad. So I think what I'm going to do is wash this board really good and go through and replace sockets, just to get a good ground level start. And then I can start to verifying whether, and if I have to use my reader to dump these ROMs and put them against ROM ident, I can do that too, to verify if the ROMs themselves are actually good and then I can test the data path and address paths to those ROMs with the fluke. So what I'm going to do, first things first, I'm going to clean this board up really good because it is absolutely filthy. So we'll make it nice and sparkly and put some nice new sockets in it so we got good connections. And I'm going to replace whichever RAM this is. I'm not sure which one it is, so I'm going to look at the schematic and find out which one is the higher 4 bits. And that's first thing to do. Okay, so I checked out the schematic, and as you can see, these are the two 2114s that are the CPU's working RAM. And the upper 4 bits is H2. You see that? Bit 4, 5, 6, and 7. That's the upper 4 bits. So H2. And you'll see I have been doing some work here. I got H2 removed. I got the 2 vector RAMs removed, and I've got the 6 program RAMs or ROMs removed. The vector ROMs and the program ROMs. If we flip it over, you'll see really happy with how it came out. No damage, no yanked up pads anywhere. That really worked out nice. Here's my the vector ROMs are way over here. And right here is H2, that 2114 that came out. Yep, this board here really has had zero work done to it, which is awesome. These are the interconnect pins, and this one, I don't know if you can see that or not. It won't focus, but there's a lot of cracked joints on here. So we'll redo it proper by removing all of the solder and then resoldering it instead of just blobbing solder balls on there. So, and here's the CPU that came out, CPU socket. Okay. So next thing I'm going to do is I'm going to give this a nice good bath. And then once it's all cleaned up and dried and everything, then I'll go ahead and repopulate sockets and put a socket here for this RAM. So that'll do it. All right, let me get to cleaning this thing up and we'll pick it up from there. Well, I decided to go ahead and dump all of the ROMs from the Battlezone board set and verify them against ROM ident. And I came up with 6 bad ROMs. J1, H1, A3, K1, E1, and LM1. The only good ones were N1 and BC3. So I'm going to have to burn some ROMs for this board. So I'm going to get to that. I'm going to burn some ROMs for it. And then it'll be about time to put it together and put the fluke to it and see if we can read these ROMs. Oh, yeah, that's a pretty big problem right there. I might burn a complete new set. So I think that's what I'll do, and just kind of put these as backup. Label them and put them away. I don't know. Maybe. I don't know. I might just use these. Oh, we'll see. Okay, while I am burning ROMs, we'll take a minute to look at the board now that it's done, cleaned, and got new sockets in it. The CPU socket, the program ROM sockets, and the vector ROM sockets. I'll flip it over and we'll take a look at it. Up here is the resolder job done on these. Those have been resoldered. And then the board was cleaned. Once I did my work, I cleaned the board again. That's the CPU, and then down to the ROMs. Nice and clean. Doesn't even look like it had any work done to it. Just how it should be. I'm gonna complete the ROMs, burning new ROMs for this thing, and we'll be ready to fire it up. At least put the fluke to it and make sure that I can get to all my ROMs and RAM. And by the way, this is a quick overview of the board once it was cleaned. You see how nice and clean it looks now. This section was completely nasty. Always better to work on a clean board. Nice and shiny. Okay. Okay, I got the board put back together. My work RAM is now good. I'm reading all of the program ROM, but I'm having difficulty with this. Sometimes it works, sometimes it won't. Sometimes I'll have to sit here and hit reset. Like right now, pin 20 is the select. And with the fluke hooked up with nothing running, it should not be trying to select any of the ROMs. But you go to the vector ROMs and they're being selected constantly. So I'm going to have to trace back, look at the schematic, and find out how these two vector ROMs are being accessed and go through that, kind of troubleshoot that. So yeah, when this is triggered, when the fluke triggers to read either of these guys, it will select that guy to dump its data onto the bus. These are both being selected at the same time constantly. So yeah, I'm gonna have to look at that. And I'm kind of wondering if these two share their own data path back to the CPU other than these guys here, because I can read these guys fine, but I can't read these. So that tells me that these have a different data path back to the CPU, like a different 245, not a shared 245. So otherwise it would corrupt the data from these coming back. So I will look at the schematic, find out what is going on, and figure it out. Alright guys, I made a little diagram here to try to simplify what I think is going on. So I will, and bear with me, I've had a couple of drinks tonight, so this might be painful, but could be fun. We have in the decoding section of the CPU of the address decoder, you have a 139 that gets the upper address bits from the CPU to determine what's gonna happen. This thing will output the high program memory, the low program memory, and the video memory, depending on these two inputs. So the high program memory is 5005 FFF. The low program, that's backwards. The high is 6000 to 7 FFF. The low is 5000 to 5 FFF. And then the video memory strictly just goes to the video RAM, and it also goes right here to these guys, and this is the select pin on these 157s. So we're not worried about the high and the low program memory because I know that works. I can read those ROMs perfectly. So that kind of tells me that 139 is probably okay, which I know it is because I probed this signal too, and this signal is present. So this is not a problem. So move on to these guys. My problem, I believe, is going to be in this area. These 157s are input by address bits straight from the CPU, and the hardware also generates address signals, and they're muxed. The only time that it's going to select the CPU stuff is when this guy sends this signal. So I don't even care about this stuff right now. All I care about is getting the CPU to be able to get its data and go through this 245 back to the CPU. So I know this signal is here. I know the CPU address bits are there because I can read everything else. So my problem is going to lie from these muxes through the ROM through this 245. And I got a buffer enable signal right here. This guy right here enables this guy. This signal right here, this buffer enable, enables this buffer. So that could be a problem. The 245 itself could be a problem. The muxes could be a problem. So that's where I'll be looking right here. Okay, I had forgotten something that is going to make my search even easier. I'm doing a long RAM test on these guys right here, those 8 2114s. Okay, if we come over here and look at the schematic, these are those 8 2114s right there, which are all triggered by these signals right here. Now, those signals come from this decoder, and the decoder gets its inputs from those muxes. Okay, that tells me, and the 245 is shared between these guys and the ROMs. There's the ROMs right there. So the 245 is shared between those. And I can get through to these RAMs good. That kind of is telling me that my muxing is fine. There is a funky signal. And I am suspecting this guy right here. That is the one that gets the same bits that this guy gets, minus the 10th line, minus 10, minus this guy right here, AM10. That one just gets AM 11 and 12, which I know AM 11 and 12 are good because they are inputting this guy. They're also going to input this guy. And that is what enables the vector ROMs. It's telling me that that's bad. Just deduction is telling me that that guy right there is no good. Because what I'm doing right now is my CPU is accessing these guys. So my CPU should be able to access these guys, no problem. So it has to be a control signal. It has to be. I don't see how it can be anything else because my 245 is working just fine to pass this data through. So logic would tell me it'll work fine to pass this data through. So, like I said, I'll be looking at this guy. Okay, I just thought of something else to take into consideration. Okay. You see up here we got AM 12, 11, and 10, and then 12 and 11. This guy right here, these 4 bits, the 4 lower bits, are the only ones that are enabling these RAMs that I'm running the test on. So that means AM 12 would have to be 0, right? Because that's going to be either 1, it's either going to be 0, 1, 2, or 3. 0, 1, 2, or 3 to enable those guys. Okay? And I don't have a problem accessing these guys. So what if AM12 is always 0? What if AM12 is always 0 here? Then I'm gonna have a problem with getting to these ROMs, right? So I could have a problem with AM12. That's something else to put in the back of my mind. AM12 could be stuck low. So AM12, yeah, see here, I just completed, this was a long RAM test, which is a much more involved test, and it went through fine, no errors. So if I can read those RAM, I should be able to read the ROM. So I'm narrowing it down a little bit. We'll be figuring it out pretty soon. Just kind of putting some ideas in my head. And taking a video of it so that I remember. Okay, I'm going through and I'm testing out these muxes, the addressing muxes. And what I'm doing is I'm just using the fluke to read at 3000 over and over and over, and I'm watching my screen up here. Let me move this a little bit out of the way so I can get a good picture, maybe. Anyway, yeah, that ain't working very good, is it? That's irritating. Here, let's just turn that off. How's that? Okay. You can see here. Now, I don't know if this is a speed thing because it's set at 20 nanoseconds so that I can see this. But you can clearly see, let me disable this. Up here, lab 0 is my select bit. And then lab 1 is my 0 input, lab 2 is my 1 input, and 3 is the output. You can see right now the output is high all the way across, where my select bit is clearly selecting 0 right here, and 0 is low, and there's no pulse. Same thing over here. Now, I don't know if this is just a timing thing. These aren't, they're not fast enough to catch that, and this is just kind of a glitch in the system. That I don't know. And I guess I won't know until I replace the chip. But if it's not a speed thing, and this is, I know it's set up at 20 nanoseconds, which is super fast. But by the looks of this and what my analyzer catches, see, I'll go ahead and hit repeat. Here's one right here where it selects 0 and 0 is high, but this stays low. So I'm not sure if that's just a speed thing where it's not picking it up, and I don't know how fast these chips operate, to be honest. But that's obviously, it looks like it's missing pulses to me. But I'm going to continue on with the other muxes. the other muxes here and see what happens. Now if you see here, when I move it up to 500 nanoseconds, which is usually what I do all of my looking at signals at, is 500 nanoseconds, which is a lot slower than 20 nanoseconds. And you see, this is kind of the, I think that's just kind of noise on the line that it's picking up as pulses, and I don't think that's a problem. Because here you have the big pulses, and so far I haven't seen anything that looks, at this speed, I haven't seen anything that doesn't look right. But I'm going to continue on with the rest of the muxes at this speed. Okay guys, my theory on the speed thing is correct. I'm doing a RAM short, which uses the same 245 buffer that the ROMs do. And if you look up here, you can see this is the buffer enable signal. It enables the 245. And you can see this is the select line, and it selects 0 right here to send that pulse. And you can see there's little errant type nonsense going on over here, which does not affect, it doesn't affect the operation at all. It's just kind of noise, really. But it's not throwing a wrench in the works at all. It's still reading, it's still working good. So that is just a speed issue. As you can see, it's now completed and it's okay. So I just wanted to kind of point that out, that it's yeah, setting that down to 20 microseconds is, or 20 nanoseconds is just too fast for the chips and whatnot to recognize that. It doesn't, it's just kind of noise is all it really is. So yeah, so far I'm finding nothing wrong with the addressing. So I'm going to start looking at with chip select or something in the data path. I'm thinking it's probably going to be the address decoding for these two guys. But I'm going to continue on, do the last few switches in this mux, and then I'm going to move on to the 139 that is used to select these, and it's, you know, go through its input bits and try to find out everything that's going on. Okay, now I'm on the 139. We'll look at the schematic real quick. This is the 139 that selects the vector ROM chips, right? So you have AM11 and AM12 are your select bits that select which output goes low based on, it's always enabled. So these two guys select which one of these goes low. And AM11 and 12 come from one of these muxes. And basically the muxes mux together signals that are made from counters and the actual address bus from the CPU. So, and if you come over here, you can see that these are basically count signals. This is AM 12 and 11. And you can see they're counter signals. And when you have 0, 1, that's, what is 0, 1? That would be 2. So 0, 1, 2 goes low. And then it goes to 3, 1, 1, which is 0, 1, 2, 3. And then it comes back to 0. So 0 goes low. And then you got 1, 0, which is 1. So 0, 1. And then it goes back to 2. So 0, 1, 2. This is basically counting 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 0, 1, 2, 3, I should say. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. 0, 1, 2, 3. And it sends a low pulse every time on that. So that counter, that 139 is actually working. So this has got to be an actual just flat out data problem. Because those are the select bits for the ROMs, which look okay to me. So we're going to have to, I'm kind of scratching my head here. There's got to be something in the data path, so maybe it's a bad trace or something's going on. So I'm going to have to, this one's fine. I can read this one. That is 3000 to 37 FF, and that's 6628. That one is good. Over and over and over. Uh-oh. Maybe not. Maybe I spoke too soon. Yeah, see, now it's getting funky. It's just data is getting totally screwed up. And I don't think it's addressing. I think this is a data problem. So I'm going to have to look at this 245. It's got two control signals, a direction and an enable. So I'm going to have to look at that. Okay, I am just sitting here kind of racking my brain over what's going on here. And if we sum everything up, these 8 RAM here and these 2 vector ROMs, that is the vector memory right there. It all shares, I believe it's this guy, 245. It's either this or it's a 245 on the board. I'm not exactly sure which one it is. But they share the same addressing from the muxes. Okay, and remember, I can pass RAM shorts constantly. I never fail a RAM short from 2000 to 2FFF. That's these guys right here. I never fail a RAM short. So that tells me that my addressing is okay. As far as the CPU address is getting passed through the muxes. These guys are selected by a 42, which is, it's either here, it's one of these chips. There's a 42 that handles selecting these guys. There's the only difference in these two banks, the ROM and the RAM, they share everything. The only difference is how they're selected, and these are selected by a 139, and these are selected by a 42. So even though I tested the 139 and it looked okay, I'm going to replace it because it's the only thing that is different between the ROM and the RAM. The paths, the addresses, everything is shared between the ROM and the RAM. The only difference is how they're selected. It's 2 different chips. So I'm going to replace the one that's selecting these 2 guys. It logically makes the most sense. So that's what I'm going to do and see what happens. Well, guess what? I'm sitting here pulling my hair out, looking at every signal in this thing. Nothing's making sense. All the signals are there and they look good. Yet I can't read these 2 ROMs. Well, guess what? I've never had this happen before. Both of those ROMs that I programmed are bad. I put known good ROMs in. This one is actually LM1. This is actually the right ROM, BC3 right here. This one is LM1, which goes like right here. which that one's signature is 5D24. I've just been sitting here hitting them over and over and over again, and they always pass. Bad ROMs. And then BC3, the one at 3000 to 37FF, is 6628. Yeah, so I programmed bad ROMs. I don't know, it's just weird. And they would always come back with something different every time. You know, there's just random nonsense. These things are junk. Trash. So I'm going to have to come up with an A3 ROM. And I have some 2816s, which I like the 2816s better because they're electronically erasable. They look like these. I'm gonna program one of those and put right here, and then pop it in and make sure I can read it good. I'm gonna leave this guy right here because that's the proper ROM for that spot, but I do need an A3, so I'm gonna burn one and try it again. But that'll be the end of it. No wonder I could not find anything wrong. I couldn't find any bad signals. I went through all of the muxes and they all looked good. This 139 looked okay, but I replaced it anyway. But I didn't need to. So, you know, I don't like wasting chips like that, really, but that's okay. Yeah, let me go ahead and burn one of these. Okay, I've got it put together, and I do have it fired up, as you can see. And here we have, you can see it's got some issues. It's kind of got some flashing going on. This is a solid screen. But it's definitely got some issues. I don't really see what it's doing, to be honest. Huh. That's pretty cool, though. It's doing something. All right. Well, I'm going to have to take a little bit of time to really look at what it's doing and try to think about what this problem could be, because right now I don't know. So I'm going to think about it for a bit. Alrighty, I put it into test mode and we get L. So if I come over and check out my manual, you will see it's a math box failure. L is a data error, low byte. So I will have to look at the schematic in the math box. So that means my board should be good, which is really cool. So let me check out the schematic for the math box and see what this low byte data error could be. So check it out. I've got it to disappear by pressing on these chips, just sockets, bad sockets. But I did get it to disappear. Let's take it out of test. See, it kind of flashed there. Just bad sockets. Well, it looks a lot better. a second, we should see our Battlezone scroll up. There it is. The monitor just needs to be adjusted a little bit, I think. It's no big deal. I'm not really concerned with that. The good deal is we got this one fixed. I'm just going to go through and replace these big guys right here. Those sockets. I do need to test the sounds. But yeah, it's just a socket issue, is all it is. Alrighty, well, I'm gonna hook up a wire or something so that I can test some sounds on this thing. Okay. Sounds work. Sorry, I'm just trying to... Oh, I should have shot. Could have blown them up. Come on, buddy. Yeah, it just gets kind of flaky because of the sockets. This will be a solid board once I get these, you know, on the math box, those big 40 pinners, you got to replace all 5 of them. You know, just old Atari junk sockets. So I'm going to call this one good. I'm not going to bore you with the details of replacing those sockets. So what exactly was the problem with this? Honestly, not much. This was a nice, kind of easy repair. ROMs had a bunch of bad ROMs, and then some of the ROMs that I programmed were no good. So we got new sockets. We got new sockets on this board, new ROM, new program ROMs anyway. This is a new one I programmed. This is an original. That's the only original ROM. Cleaned it up. I'm going to replace all of these sockets. And then that'll be it. Hear it just flaking out with that sound. The sounds are generated on this board. It's totally flaky. Okay, cool. Hear that? And thanks for watching, guys. Take it easy. See you on the next one.